Okay, guys, this lesson is on factoring by grouping. Some of this stuff we've seen before, and some of it's just a little bit new. All right, we're going to start with factoring cubic polynomials. We saw this in class last week, but we didn't explore it, so we're going to today. Okay. Okay, so we have here, we'll call this example 1. All right, we're going to factor this entirely. The first thing that I'm going to do is pull out I'm actually going to go ahead and split it up into 2 before I pull out a GCF. There's nothing that comes out of all of those, so I'm just going to factor this by grouping. So 15 q to the 3rd power plus 40 q squared, okay, will be one of them. And then plus 3q plus 8. Okay. And actually, what we're going to do is pull out a GCF of this binomial. I can pull a 5 out of that, and I can also pull, I got 3 q's here and 2 q's here, so I'm going to pull out 5. The max I can pull out is q squared. Okay. Now 15q cubed divided by 5q, I'm left with 3q. And then 40q squared divided by 5, I'm just left with 8. The only thing I can pull out of this is a 1. I'm left with 3q plus 8. Okay. And then my 2 binomials here are the same. 3q plus 8. And it's going to be times those common factors of what we pulled out. 5q squared plus 1. Okay. Example 2. What we're going to do is group these. Okay, again, 12k cubed minus 27k squared plus negative 40k plus 90. All right, I'm going to pull out my GCF, my greatest common factor from these first 2. I can pull out a 3, and my smallest exponent is the squared, so k squared. Okay, I'm left with 4k minus 9. I'm going to pull out a negative 10. I can't pull out a k because there's not one there. So I'm left with 4k minus 9 here as well. Good. So my first binomial is 4k minus 9. Okay, I notice they're the same, so I did the right thing. And then my greatest common factors, 3k squared minus 10 is my second binomial. Now I'm going to factor polynomials completely. Okay, this is a little bit more in depth than the stuff that we've been doing, so we're just going to continue with it. The first thing that I notice here, what I can do, I can pull something out of this entire expression. I can pull out, let's see, and actually there's a mistake. This should be 8, not 18, but I can pull out a 4, okay, from the whole thing. I can't pull out any p's because this last term doesn't have a p though. So it'll be 4, okay, and then I'm left with 8 divided by 4 is 2p cubed minus 8p squared plus 7p minus 28. Okay, so now I'm going to group these together. Okay, so I have 2p cubed minus 8p squared plus 7p minus 28. And now pull out your greatest common factors. Leave that 4 on the outside still. Out of this first binomial, I can pull out a 2, and my smallest exponent's squared, so 2p squared. And then I'm left with just 1p minus 8 divided by 2 is 4. I can pull out a 7, but I can't pull out a p because there's not a p in this term. All right, so then I'm left with p, and then 28 divided by 7 is 4. All right, so let's rewrite. That 4 stays on the outside of my binomials. My common binomial, factoring it out, would give it as, make it 4, or excuse me, p minus 4. And then my second binomial comes from those common factors, 2p squared plus 7. And that's that final answer, that whole thing right there. Okay. Example 4 here. That was 3. Example 4. I have to the 4th power right here, to that 4th degree. What I'm going to do, I'm going to look to see, can I pull anything out of all of them? Well, nothing from the coefficients, but I notice that they all have a w. The smallest w exponent is just to the first, so that's what I can pull out. I'm going to pull out that w. Okay? And then rewrite it. I'm left with then 3w cubed minus 2w squared plus 18w minus 12. Now go ahead and continue to factor by grouping. Okay, let's group those together. So I have then 3w cubed minus 2w squared plus 18w minus 12. And pull out your GCFs of each. Okay. I can't pull anything out of the coefficients here, but I can pull out a w squared. So I'm left with 3 and then 1w minus, didn't touch the coefficient, but I took the w squared. Okay. Here I'm going to see I can pull out a 3, but a greater common factor I can pull out is a 6. And then I'm left with 3w minus 2. All right, so then let's rewrite. W stays on my outside. My common binomials, factoring those out, would be 3w minus 2. And then my last part are those common factors, was w squared plus 6. Okay. All right, now what we're going to do is factor to find dimensions of rectangular prisms. Okay, so applying this factoring to other scenarios. All right, we're going to find the expressions for possible dimensions of each rectangular prism. So it's telling me that this volume of the rectangular prism is this expression here, and I'm going to find the possible dimensions. Okay. So in order to do that, I'm going to see, can I pull out any common factors? Nothing from the coefficients, but I can pull out a y. Okay. So then I'm left with 3y squared plus 14y plus 8. And now I'm doing the same thing here. This is not a coefficient of 1, it's a 3, obviously. So I'm going to take 3 times 8. I'm going to need something that's going to multiply to give me 24, but add to give me 14. Okay? So I could do 1 times 24, but that won't add to 14. 2 times 12, ooh, that will. 2 and 12. Remember, I'm going to try to get my common factors to pull out the greatest common factor. So I'm going to put that 12 by the 3y. Okay, so 3y squared. This 14 broke into a positive 12y. And then it also broke into a 2y and then plus 8. Pull out common factors for each. I can pull out a 3 and a y. So I'm left with y plus 4. And here I can't pull out a y, but I can pull out a 2. And I'm left with y plus 4 as well. So if I wrote out my factors, it would be y times, okay, I have this factor, this binomial, and the common binomial. So y plus 4. So that none of that has been different until this point. Now I'm telling the dimensions, expressions for possible dimensions. Well, that's what we just found. Y is a possible dimension. 3y plus 2 is a possible dimension. And so is y plus 4. Okay? All of these are possible dimensions to find that volume of this rectangular prism. All right, and then that last one, we're doing the same thing here. Okay? I can pull out a c, and I'm also going to be able to pull out a 4 from each of those. So I'm left with then c squared. 52 divided by 4 is 13. Left with a c plus 160 divided by 4 is 40. And I already pulled out the c. Okay? That's a coefficient of 1, so it's going to have to multiply to 40, my two terms, my two factors, and it's also going to have to add to 13. 1 and 40, 2 and 20, 4 and 10, 5 and 8. Ooh, that's good. 5 times 8 will give me 40, and if I add them, it'll give me 13. Okay? But I'm going to probably want this, let's see, probably the 8 to go by the 40, so I'll be able to pull an 8 out of that. So I'm going to split this 13c. Let's rewrite this beginning. C squared. I'm going to put the positive 5c here. And then I'm going to make that 8c here because I'm going to want to pull it out of the 40. My greatest common factor in the beginning is just a c. So I'm left with c plus 5. Okay, and then I'm left, I can pull out an 8. I'm left with c plus 5. So rewrite them like we normally have. 4c, it's times that constant binomial, c plus 5, times, this common factor, c plus 8. So the possible dimensions for my rectangular prism are 4c, c plus 5, and c plus 8. Okay, those are the possible dimensions. So if I found c, if I knew what c was, I could tell what the dimensions of the rectangular prism are based on factoring that expression. All right, the code word for this lesson is, oh, this is bad. I don't know. Friday, as in the day of the week, Friday. I don't know why it's so hard to think of the code word. So go ahead and make sure that you've done that left-hand page, and if you have any questions, please email me with those.